Hello everyone. Today we will discuss about transition and inner transition elements. Okay. So name of chapter is what? Transition and inner transition elements. Okay. Chapter number 8. This chapter is also have highly weightage and this is from paper 1. So for this chapter you need to remember all the periodic table. Okay, this is just a periodic table. Now look at here. This is S block element, this is P block element, and this is D block element. So from scandium to zinc, this is what 3D series. Okay, and this series all D block elements are called as what? Transition elements. Okay, they are called as transition element. So we can say D block element is nothing but what? Transition elements. Okay, now look at here. This is what? 3D series. Okay, from third group to 12th group there is what? Presence of D block elements. So this is first element, this second, and this is lanthanide to lutetium. Okay, La series lanthanum to lutetium, and this is what? Actinide. Okay, this is actinide. So these elements, this is called as what? From 57 atomic number. Okay, atomic number of lanthanide is what? 57, and atomic number of lutetium is what? 71. So from lanthanum to Lu means what? From lanthanum to lutetium, this series is called as lanthanide. This series is called as lanthanoid, also called as what? Lanthanum. So from atomic number 57 to 71, this series which is present in D block. Look at here. This series which is present in what? D block. Okay. Called as what? Inner transition element. Inner transition elements. From 57 to 71, this series is called as what? Lanthanoid series. Lanthanoid, also called as lanthanum. Lanthanum series. Now look at here. Below that lanthanoid series, there is what? Presence of AC and LR. Actinide to LR. And atomic number is what? From 89 to 103. Okay. This series is called as what? Actinoid. Actinoid series. This series is called as actinoid series. So D block from third group to 12th group. Okay, this is called as D block element, also called as transition element. Okay, and this is what? La series. Okay, from lanthanum to lutetium, atomic number 57 to 71, and actinoid series. The both series are called as what? Inner transition element. Why lanthanoid and actinoid called as inner transition element? Because they are present in between transition series. Now look at here. This periodic table is actually, they are three-dimensional structure. This is what? Actually they are three-dimensional structure. This is S block which is present in 2D series, two-dimensional. This is also present in 2D series. This is D block element. So inner transition elements are present, means what? Lanthanum and actinide present in between that D block. ऐसे present रहता है. Actinide is also present in this way. That's why lanthanide and actinoid are called as inner transition element. D block elements are called as what? Transition element. But lanthanoid and actinoid are called as what? Inner transition element. Okay, so in this chapter we will discuss about the transition and inner transition elements. Now next point is what? Oxidation state of first transition series. So first transition series means which series? This SCTI, Cr, Mn, Fe, Co, okay, Ni, copper and zinc, okay, scandium, titanium, vanadium, chromium, okay, manganese, iron, okay, cobalt, nickel, copper and zinc. This is what iron. This is not a iron. Okay, how we can pronounce that Fe? Iron. Okay, so this series is called as what? First transition series, or we can say called as 3D series. Now oxidation state of that 3D series, okay, means metal, all metals, always remember students, all metals, they are having oxidation state. They are having oxidation state. So oxidation state means what? Ability to loss of electron. So this concept is belonging from redox reaction. So redox means what? Reduction and oxidation takes place simultaneously. So oxidation means what? How we can define oxidation? Loss of electron. Loss of electron means what? Oxidation. So always remember, metal having ability to lose the electron. Metal never ever accept the electron. Metal are always having tendency to lose electron. That's why metal always carry oxidation state. Okay, for example, M metal carry plus 2 state. So plus 2 means what? This metal lost 2 electrons. This metal lost 2 electrons. This metal lost 2 electrons. Okay, metal 3 plus. Okay, oxidation state of this metal is suppose 3 plus. Meaning of this is what? This metal lost 3 electrons. Okay, so oxidation means state means representation of oxidation state, or we can say oxidation state means what? The tendency to lose electron. And metal having tendency to lose electron, they can easily lose the electron. Okay, so 3D series, generally that 3D series having oxidation state is what? Plus 2 and plus 3, plus 4 is also there. Okay, so 3D series having this type of oxidation state, plus 2, plus 3 and plus 4. So this is all about oxidation state of first transition series. Now next point is what? Physical properties of first transition series. Physical properties of first transition series. So first transition series, for that purpose you have to remember which elements are present in first transition series. Okay, look at here. First element is what? Cadmium, then titanium, then vanadium, chromium, manganese, not a magnesium, manganese. Okay, then Fe means iron, cobalt, nickel, copper and zinc. 1 2 3 4 5 6 7 8 9 10. Okay, atomic number of cadmium is what? 21. Titanium is 22, vanadium 23, 24, 25, 26, 27, 28, 29 and 30. This is what? Atomic number. Next is what? Electronic configuration. Electronic configuration. This is very important point. This is very important part of the chapter. Okay, so atomic number of cadmium is what? Argon, 4s2, 3d1. Atomic number of titanium, argon, 4s2, 3d2. Vanadium, argon, 4s2, 3d3. Now chromium, argon, 4s2, 3d4. Now look at here. I mark as a star. Look at here. Okay. We'll discuss later on. Next is what? Argon, 4s2, 3d5. Iron, argon, 4s2, 3d6. Cobalt, argon, 4s2, 3d7. Nickel, argon, okay, 4s2, 3d8. Copper, 4s2, 3d9. I again mark as a star for copper and chromium. Next, argon 4s2 3d10. Now look at here, chromium and copper. According to above principle, electronic configuration of chromium is what? Argon. Okay, argon 4s2 3d4. Look at here, argon, chromium का argon 4s2 3d4 according to above principle. But this is what? 4s2 and 1 2 3 4. 1 2 3 and 4. This is 4D structure. Look at here, 1 2 3 4, and s orbital contain 2 electrons and d orbital contain 4 electrons, but this is very unstable structure. So to avoid that instability, one electron, okay, transferred to the d orbital. And atomic structure of chromium is what? Look at here, 1 2 3 and 4. So 1 2 3 4 5 6, total 6 electrons are present in the outermost shell. So 1 2 3 4 5 6, this one electron, okay, will transfer from the 4s to 4d orbital. Okay, 4s to, not 4d, 3d orbital, 4s to 3d orbital. So electronic configuration of chromium is what? Electronic configuration of chromium is 4s1 3d5. Look at here, 4s1 3d5. This is actual electronic configuration of chromium. Now copper. According to above principle, electronic configuration of copper is argon 4s2 3d9. But this is very unstable structure. Okay, that's why shifting of electron will take place. This is, look at this original structure, 1 2 4s2 and 3d9. So 1 2 3 4 5 6 7 8 and 9. This is only one electron is unpaired. That's why this structure is very unstable. Okay, and because of this reason, one electron transfer from 4s to 3d9. Okay, so actual structure of copper is equal to what? Look at here, 1 2 3 4 5 6 7 8 9 10 and 11. Total 11 electrons are present. So electronic configuration of copper is what? 4s1 3d10. Actual structure is what? 4, or we can say expected structure is what? 4s2 3d9. But actual, or we can say observed structure is what? 4s1 3d10. This is because of Hund's rule. Okay, according to Hund's rule, if this is what? D orbital or D block element, which contain what? Total 1 2 3 4. Okay, now this is 3d1 3d2 3d3 4 5. If all electrons are unpaired, okay, this orbit is what? Half filled, and all electrons are what? Unpaired. So we can say such type of structure or d5 structure is what? Stable in nature. Suppose d10 electron are there. Okay, so 1 2 3 4, 1 2 3 4 5 6 7 8 9 10. Look at this structure, d10 means what? 10 electrons are present. So all electrons are what? They are all are paired. Okay, and this is all are unpaired, half filled. This is half filled and this is full filled. Both structure are what? Stable in nature. Both structure are stable in nature. But suppose in this case, suppose d4 is there, d4 structure is there, 1 2 3 and 4. So 1 2, 3, 4. This electron is not half filled. Okay, the orbital is not half filled, or we can say they are not completely filled. They are highly unstable in case of D4 and D9. Okay, in case of D4 and D9, the structure is highly unstable. Look at here, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so one unpaired electron is there, and this is what one unpaired block is there. So because of this reason, such type of structure is highly unstable. So in case of chromium, D4 means highly unstable structure, and copper highly unstable structure. To avoid that instability, or we can say to gain the stability, one electron is transferred from s orbital to d orbital. Here is also same thing is takes place. One electron is transferred from s orbital to d orbital, and such behavior of copper and chromium is called as anomalous behavior. Okay, why this anomalous behavior will takes place? Because of stability, to gain the stability. So this is very important point, this is very important question. Why copper and chromium show anomalous behavior? Anomalous behavior, meaning of anomalous is what? Abnormal behavior. All elements which are present in periodic table, they are follow above principle. Now what is above principle? Above principle is a principle, obviously the you will get full idea about that above principle, just refer 11th standard book. Okay, sorry. So according to above principle, all elements which are present in periodic table, they are follow above principle, but exceptional cases what? Copper and chromium, they are not following above principle. Why? To maintain the stability of that particular element. To gain the stability or to maintain the stability, they just transfer, they just shift one electron from the s orbital to d orbital. Okay,